Okay, so this word problem goes like this. Two cars go in the same road. Two cars are going in the same road at the same speed. A picture was taken, and this is the picture, okay? Look at that picture, beautiful, 4K, really high definition. And what can I say? Great photographer, I am a great photographer, okay? So that picture was taken, and we know that the red car has a mass of 2000 kilograms, and the blue car has a mass of 2500 kilograms. That means with the people inside of it, it's 2500 kilograms. Okay? Now, what the problem is asking you to find the gravitational force between them, knowing that the distance is 20 meters. Okay? So the distance that is between the two cars is 20 meters. 20 meters. Okay? Knowing that, we need to calculate the gravitational force. Now, the main equation for gravitational force is this one. Okay? So from this equation, we can get isolations, okay? From this equation, you can get isolation for the masses, okay? Because we have two objects, you can find two masses, okay? The mass of the object 1 or the mass of the object 2. But you can also find the distance between objects. So these are the possible isolations for this formula, okay? So I'm going to zoom in a little bit more. Okay, that's better, okay? So what formula do I need to use for this problem? What formula I'm gonna need to use for this problem? So we have the main formula and we have the isolations. Okay, we have one isolation, second isolation, and third isolation. So which one I'm gonna be using for this topic?
The main formula.
The main formula. Okay, you don't need to do anything else. Just apply the main formula. So solution process, quite simple. I'm gonna be using the main formula. So I'm gonna copy and paste because I'm this level of lazy. Don't tell anyone. It's between us. Okay. So you write the formula over here, and let's see. Okay, remember that G is a constant. That means there is a value that is never going to change. It is an universal constant. Never gonna be changing. Okay. So that G is actually 6.673 times 10 to the negative 11th power Newton meter square per kilogram square. I'm gonna ask you something pretty off the class, you know. Just answer to me this, please. Very, very much important. Tell me, Xavier.
No, no sé me sale.
Okay. Okay, just plug in the givens. The masses of the car. Remember, we have two cars in the picture. Beautiful picture. 2000, 2500. Oh, so disappointing. Nobody watches Claymore. That's one of my favorite animes. It's okay. I forgive you. I forgive you, okay? Now the distance that is between the two cars is 20 meters, so 20 meters here. Just remember they are raised to the second power. Now in your calculator, how you do it is this, okay? In your calculator, what you do is when you input givens 6.673 exponential, which is the key that is next to ounce, okay? Then the negative sign 11 times the car 2000 times the other car 2500. Then you divide by the distance between the car that is 20 meters, but is raised to the second power. Is it the answer that you got?
Yes, miss.
Okay, that is very good. The correct use of the calculator will define if you get a good answer or not. So it is very important that you follow the steps I give you. In what units do we measure the gravitational force?
Newtons.
Newtons. Okay, what about this question? Can you answer to me, please? I really need to be very specific. That is not Dexter's lab. Well, unlucky, I guess. Okay. Bueno, guys, this will be like the answer. Definitely just plug in the givens, apply the formula, plug in the givens in the calculator correctly, and you will get the nice formula. Now you get the answer to be Newton because the way you cancel the units. Kilogram makes kilogram squared divided by kilogram squared are cancelled. And then these are already in meter squared, and meter squared are also going to be cancelled. Close, but not close enough. So unlucky. Questions about the first exercise? Nope. Let's try. Okay, let's. Okay, this is an example for gravitational force. Same topic, but now we're gonna look for something different. Tell me, Karen.
I was about to ask you if you can make one looking for mass.
Exactly. This is one for where we need to look for mass. Okay. So this is exactly that kind. I knew it. Okay. I knew that you were going to ask for it. That's why it is already there. Okay, so gravitational force is a topic that you can apply to every single object that has a mass, but more importantly in celestial bodies like stars or planets or anyway, asteroids, etc. Okay, satellites, etc. Astronauts. Okay, yeah, I will stop now. You get the point, I guess. So the gravitational force between Ganymedes and Jupiter is 1.636 times 10 to the 22nd power Newton. Jupiter's mass is 1.9 times 10 to the 27th power kilograms, and the distance between the two bodies is 1.071 times 10 to the 6th power kilometers. What is Ganymedes' mass? So we're talking about two celestial bodies, okay? One of them is Ganymedes, which is one of the Jupiter's moons, okay? I don't know if you know or you've seen about the Jupiter has a lot of moons. Well, one of them is Ganymedes, the main one, okay? It's a moon, a satellite, okay? And well, Jupiter the planet. Okay, so I have two bodies. I'm gonna draw them just because I'm an amazing person. I'm gonna draw it. Look at it, beautiful. Okay, this is Jupiter. What I do know about Jupiter is that it has a mass of 1.9 times 10 to the 27th power kilograms. Okay, that's what I know about Jupiter. And Ganymedes, I'm gonna draw it here. A little bit far. Okay, Ganymedes has a mass. I don't know which mass is that, but I know I had to find it. So my mass of my object 2 is gonna be unknown. Jupiter is gonna be my object 1. Okay, Ganymedes is gonna be my object 2. What I do know about the objects is that the distance between the two masses is well 1.071 times 10 to the 6th power but kilometers. Okay, so if I measure, okay, from center to center, the distance between the two objects is going to be, well, the one I mentioned is 1.071 times 10 to the 6th power but kilometers. So those are all my givens. Okay? Now what I need to do is, I'm gonna write the givens like the right way. Okay, so my givens are mass 1, which is Jupiter, 1.9 times 10 to the 27th power kilograms. Mass 2 is what I actually need to find. I do know the gravitational force between them, that is 1.6 times 10 to the 22nd power Newton, and I know the distance between them is 1.071 times 10 to the 6th power kilometers. Okay, so I have kilometers. I don't need kilometers. I always need meters. So I'm gonna do the conversion directly from the givens. Okay, knowing that the conversion factor between kilometers and meters is that in 1 kilometer you have 1,000 meters, the answer that you should get is 1.071 times 10 to the 9th power meters. Okay, cancel kilometers, kilometers. Now, how I did that, how I got this answer, didn't do it in the calculator, but I did it mentally. Doing things mentally is very good. Okay, so for example, I am multiplying times 1,000. 1,000 has 3 zeros. Okay, scientific notation is about counting zeros for that saying. So if my scientific notation gives me an index of 6 or an exponent of 6, all I do is I'm going to add the exponent, which is 6, plus the number of zeros. In this case, my number of zeros is 3. So I get this magical number 9 right here. I just add to the power, I just add the 3 zeros, and I have my answer already in scientific notation. Pretty simple. That way you don't need to use a calculator at all times. But if you want to use a calculator, go on, use it. Take your time. If you're not confident enough, just do it. Okay. Well, anyways, that's what we have now. What do we need to do? Okay, solution process. Quite simple. This is your main equation. If g equals to g, mass 1, mass 2, divided by the distance between them to the 2nd power. That is, well, that is my equation, okay? And I'm gonna look for the mass of my object too, which is Ganymedes, okay? So this one I need to find. So R is divide, goes to the other side to multiply. So my equation is gonna be Fg times R to the 2nd power equals G M1 M2. So these M1 and G are multiplying, so I'm gonna take them both to the other side to divide. And now my equation is already isolated for M2. Now, I don't like to write my equations like this, so I always put my unknown in the left because I feel more comfortable, sorry. So this will be my isolation. Okay. You start by moving R, and so on. That's all. You can use the equation directly. Okay, it's gonna be fine. So all I do now is I just plug the givens. So I say M2 mass of Ganymedes equals to the force given as 1.636 times 10 to the 22nd power Newton times the distance between them in meters, which is 1.071 times 10 to the 9th power meters. All these divided by G, remember 6.673 times 10 to the negative 11 Newton meter square per kilogram square, multiply the other mass, which is the mass, Jupiter's mass, that is 1.9 times 10 to the 27th power kilograms. So in here, okay, this radius is raised to the second power. Okay, so meter square, I'm going to be cancel this meter square, newtons with newtons, and this kilograms with this kilogram over here, but 1 kilogram is going to be remaining. Now, what is the mass of the object 2? The Ganymedes mass. How do we get it in the calculator? Pretty simple. Take a look. 1.636 exponential 22 times 1.071 exponential 9 raised to the second power divided by 6.673 exponential negative 11 divided by 1.9 exponential 27. Did you get the same answer as me? Did you get the same answer as me? Okay, I will
Yes,
ask you again. Did you get a different answer? Did you get a different answer? Remember, everything in the top multiplies, everything below divides. That's why we say divided by 6.673 and then we divide again by 1.9 exponential 27.
Means if we pass Jupiter's mass to the mass 2, then the formula will change, right? Only mass instead of mass 1, really mass
Exactly.
2.
If you were looking for the other mass, for example, Jupiter's mass is going to be mass 1 equals to Fg R2 divided by G times M2. That will be the equation. Just exchange the subtract. That will be okay. If you change the subtract, it's the same. So you can see very simple process. I think the process is simpler than the calculator is. But still, that's my cat. Bueno. So that will be the case if you need to find the mass. Now, another topic that I want to review is centripetal acceleration, but I don't have the time to review it all. But you know, the topic is quite simple. I guess that you remember. If not, go watch the videos too. It says a subject in a large centrifuge has a radius of 8.9 meters and a centripetal acceleration of 20 g. That is important. Okay. It says that the centripetal acceleration is 20 g, and they are giving you the value of g. Now, how do you understand this concept in the end? Okay. 20 g means 20x gravity. Okay, 20 times The value of gravity is going to be the centripetal acceleration. That's what 20g means. If it says 15g, is 15 times gravity. Okay? Bye. Adios. Bye. My cat bothers a lot. Sorry. Okay, so that's what it means. Okay, 20g, that's what it means. So let's focus on the exercise. It says that the radius is 8.9 meters and the centripetal acceleration is 20g, and I need to find tangential speed of this object. So I'm gonna write my givens. Okay. Okay, the first given is okay, the radius 8.9 meters and AC. AC, they're telling you that it's 20g. As I told you, what 20g means is 20 times gravity. And this in the end is 196.2 meters over second square. Okay? And they're asking you to find VT. Okay, tangential speed, unknown. So solution process is quite simple. Okay. Okay, the main equation for this centripetal acceleration is AC equals to VT squared divided by the radius. That's the main equation. Since I'm looking for VT, okay, and the radius goes to the other side to multiply, so you will have AC times R equals to VT squared. And to get rid of the square, what you do is you apply the square root but in both sides of the equation. So in the end, the equation to calculate VT is equal to the square root of centripetal acceleration times the radius of the circular path. All we do after is we just plug in the givens. So we say VT is equal to the square root of 196.2 meters over second square times the radius, that is 8.9 meters. Okay. So in the calculator, what I do is this 196.2 times 8.9. 196.2 times 8.9 equal, and then I get the square root of the answer. Okay, that is in scientific notation, but without scientific notation, it's gonna be 41.79. Did you get the same result as me?
Yes, miss.
Okay, VT is a measure in meters per second. That will be the final answer. Now let's try another one. Before we leave. The example number 2 of the topic, centripetal acceleration. Okay, this is example number 2. This is example number 1. Okay. It says a race car speeds along a curve with a tangential speed of 75 meters per second. The centripetal acceleration of the car is 22 meters per second square. Find the radius of the curve. So, they're giving me a tangential speed of 75. They're giving me a centripetal acceleration of 22 meters per second square, and then it says find the radius of the curve. Okay, find the radius of the curve. So I need to list the givens. Okay. My givens are, guys, do you listen to me?
Yes, Miss.
Okay. Sorry that there's a little delay here. Okay, the tangential speed bt is equal to 75 meters per second. Centripetal acceleration, which is AC, is 22 meters per second squared. And I need to find the radius. Okay? So again, solution process quite simple. This is the main equation. Okay? AC equals VT squared divided by the radius. If I need to find the radius, all I do is I change the position of the two. Okay? So my radius is equal to VT squared divided by AC. That's going to be the equation isolated for the radius. And then I say radius equals to VT, which is 75 meters per second, raise it to the second power, and then divide by AC, that is 22 meters over second squared. In the calculator, pretty simple, the procedure will be 75 to the second power divided by 22. But, I always forget how to write it in decimals. Bueno, we'll do it with my physical calculator better. I'm gonna write the answer. I'm gonna try. I got 255. Did you get the same answer as me?
Yes, Miss.
Yes, Miss.
Okay. So here second square cancel with second square, and one of the meters is cancelled up with the meters below. So the final unit is going to be just meters. Oh yes, it was just shift. This is the answer in scientific notation, but if I just want the full answer. Anyway, I'm not gonna do that. So this is it, guys. This is what I wanted to review today. If you haven't done the homework about gravitational force, you have these two more examples so you can apply in the homework. The quiz is going to be about gravitational force only, okay? But the review and the homework for this week is going to be of the topics that I review, okay? So far, the homework includes two topics. With the topics I explained on Wednesday, it's going to be a little bit more topics. But in the end, it's quite simple. This is going to be another homework that you will have to practice. Any doubt on the exercises? Okay, bueno. Guys, goodbye. This is it for today. See you tomorrow.